Hello and welcome to this lesson where we will show you how to plot box plots in R using the ggplot2 package. This lesson explains syntax and provides clear step-by-step code examples that you can follow along with if you download the files that go with this lesson. Once you get set up, let's get started. What you're seeing on screen is a side-by-side box plot. It visualizes the distribution of a continuous variable split by the values of a discrete variable. This plot shows the variation of GDP per capita here on the y-axis split by 5 different world regions. Here are the learning objectives for this lesson. We'll learn how to create a simple box plot, customize them using ggplot aesthetics, reorder the boxes on a side-by-side box plot, and add points on top of our box plot to provide additional insights. Before we get into the syntax for a ggplot box plot, let's quickly review what box plots are and how they're structured. Box plots are a type of data visualization that shows summary statistics for your data. More specifically, box plots summarize what we call the 5 numbers summary. The two main parts of a box plot is the box and the whiskers. The different parts of the box and the two ends of the whiskers visualize our 5 number summary. The box itself forms the core of the box plot. It extends from the first to third quartile, Q1 to Q3, with a line in the middle that represents the median. The range of values between Q1 and Q3 is also known as an interquartile range. The whiskers, which extend from either side of the box, indicate variability outside of Q1 and Q3. The minimum and maximum whisker values are calculated by this formula. Everything outside the whiskers is represented as an outlier using dots or other markers. Altogether, this gives us a lot of useful information about how the data are distributed. However, being a 5 number summary, we might miss important characteristics or patterns in the data because we can only see this high-level summary statistics. If the amount of data you're working with is not very large, you can add a layer of points over the box plot to make the graphic more insightful. Here you can see the raw data points that are used to calculate the summary statistics shown in the boxes. Now that we've reviewed the parts of a box plot and the pros and cons of using this visualization, let's learn how to plot them with ggplot2. We're going to start by loading in the packages and data you'll need for this tutorial. I encourage you to download the lesson files that come along with this video, open them on your computer, and code along with me. There'll also be practice questions throughout this lesson, which you can do on your own to check your understanding. Make sure you run the setup chunk at the beginning of the RMD in order for the practice questions to work properly. The packages we'll need for this lesson are tidyverse, gapminder, and here. The tidyverse package is a meta package that also loads in ggplot2, which we need for data visualization. And we need the gapminder package, which contains the dataset we'll use for box plots. Finally, we load in the here package, which helps us use project relative file paths. You can run this code, and these packages will be loaded into your R session. Next, let's look at the dataset. For this lesson, we'll be visualizing global health and economic data from the gapminder data frame, which we've encountered in previous lessons. We won't need to load in this data from a CSV because it's built into the gapminder package, which we loaded earlier. Now we can run head gapminder in order to look at the first few rows of the data. Gapminder is a country year dataset with information on 142 countries around the world, which are split into 5 continents or world regions. Data were recorded every 5 years from 1952 to 2007 for a total of 12 years. Now let's talk about syntax needed for plotting box plots with ggplot2. The geometry function we need is called geom_boxplot, which is pretty straightforward and easy to remember. This syntax should look familiar to you if you've been following along with the course so far. If not, I encourage you to look back at the Intro to ggplot lesson, which will introduce you to the fundamentals of ggplot syntax. Now let's start with a simple box plot of just one numerical variable. Take a look at this figure here. We give it the data, aesthetics, and geometries, which are the three required layers, as we know, in order to make a box plot. We can plot a variable to the x-axis and one to the y-axis. For a box plot, we can make a single numerical variable and split it or break it out into several boxes to create a side-by-side box plot like we saw before with the GDP and the continents, or we can just make one box just for that numerical variable. We'll start off with a simple one like that. We're going to start by specifying just an x argument and not the y to get the one box. We're going to use the life expectancy variable from the gapminder data frame. So to create the simple box plot, we start with the ggplot function, give it the data argument and set that equal to gapminder, which is where we get our variables from. Then our mapping, we're mapping the x aesthetic, which will be life exp, the name of the life expectancy variable. And finally, we add our boxplot function, geom boxplot. Now run this code and look at the resulting box plot. Here, since we've mapped a single numeric variable to the x position, ggplot outputs a horizontal box plot of that variable. To create a side-by-side box plot of life expectancy broken out by the categories of the continent variable, we'll specify both x and y position aesthetics. Start again with ggplot, have the same data and mappings as before, but we'll add an additional mapping. So we have x equals life exp as before, and now we'll also add a y equals to continent. Then again, geom boxplot at the end. Notice that the orientation has changed because we mapped two different variables to x and y. ggplot knows that continent is a categorical variable, so it creates a separate box plot for each factor in the continent variable. This is very useful for comparing distributions across categories in your data. ggplot knows that continent is a categorical variable, so it created separate box plots for each value of continent. That's why we have 5 box plots instead of 1 that was in the previous variable. This kind of side-by-side box plot is really useful when you want to compare distributions for different subsets of your data. You'll notice here that these are horizontal box plots. You might want to change the orientation to vertical box plots. In order to do that, you just need to swap the x and y mappings within ggplot. So let's do that for this plot here. I'm going to go back to the code we used to create this plot and then swap life expectancy and continent. I'm going to replace x with continent and change y to life expectancy. And now we get a horizontal box plot. We'll be using this horizontal orientation for the rest of the box plots in this lesson. Next, we'll change the color of the boxes. I'm going to go ahead and start with the same code that we had before. Here we want to fill each box with a different color corresponding to the continent. Since we want the color to match the values of a variable, this is a mapped aesthetic and not a fixed aesthetic. Think back to when we learned about these. Mapped aesthetics go in the AES function, whereas fixed aesthetics go straight into the geom function. Here I'm going to add fill equals to continent so that the fill colors correspond to the continent variable. While the fill argument has colored the interior of the boxes, we can use the color argument to change the outline color as well. Other arguments that we've used previously in lessons also apply to this, like alpha for transparency. Let's go ahead and change these next. Here I'm going to go ahead and set color also equal to continent, so the border and fill colors will match each other. But I want to make the boxes more transparent. Let's say I want to set the opacity to 60%. That would be alpha equals 0.6. Now this is a fixed aesthetic, so it goes inside Boxplot and not inside AES like we did with the other aesthetics so far. Here let's add alpha equals 0.6, and in the resulting boxplot you can see that the border color matches the fill color, but the fill is slightly more transparent. Now it's time to practice what you've learned so far. You'll be using the Gapminder data frame again, but this time we'd like you to make a boxplot of the GDP per capita variable instead of life expectancy. Make additional modifications to your boxplot by setting fill color equal to continent, and we'd also like you to set the line width of the border of the boxes. You can use the same argument as you did for line graphs previously. If this is your first time coding along and doing these practice questions in the RMD, I'll do a short demo of how to plot and check your answers so that you know you're doing it right. First of all, you'll want to go to this write code to create your plot section and try to get the right answer. I'm not going to show you what the right answer is, so I'll just create the previous plot that we did in the examples from the lesson. Here I'll paste this code in, and let's say I'm just going to pretend that that is the correct answer. When you think you have the right answer, you're going to want to delete this text that says your answer here and replace it with the code needed to create your plot. So just paste in your answer code there and run this code. Then make sure that Q1 or Q2 or Q3, depending on the question, shows up in your environment tab. Next, you'll go to this check function here. Each question has its own check function. You don't need to put any inputs in it. Just run that and it will tell you whether you got the answer right or wrong. I purposefully put in a wrong answer, so here it's telling me that it's not correct. So you can keep trying until you get the right answer. If you'd like a hint, there's also a hint function for each question. So go to the next part and run the hint function for that question, and it will give you a series of things to check and some pointers on what arguments or things you might be missing in your code. So pause now and go to the RMD on your computer and do the practice question. When you're done with it, you can come back and I'll show you what the correct plot should look like. Welcome back. By now you should have done the practice question and checked if you had the right answer in your RMD. For visual reference, this is what the correct plot looks like. You can see that the y-axis is GDP per capita, the fill color corresponds to continent, and the line widths around the boxes have thicker outlines because you set the line width to be 1. As a follow-up, here is a second practice question. This one asks you to build on your code from the last one, so you can just copy and paste over your correct answer from question 1, and we're asking you to add a scale function to this code as a new layer and transform the y-axis to be a logarithmic scale. We've covered this previously in the line graphs lesson, so you might need to refer back to that or check the hint function if you have trouble remembering which function you need to use in order to transform the y-axis. So again, pause here, go to your RMD, and come back once you're done. Welcome back, and I hope you were able to figure that out. The correct answer for practice question 2 looks like this plot over here. You can see that it's still GDP per capita, but the y-axis has been rescaled to a logarithmic scale, so it's not linear anymore, and you can see that the boxes, which used to be smushed around the lower end of the y-axis, are now a little more spread out, and it's easier to read and compare the distributions. In this next section, we're going to learn how to reorder box plots in ggplot2. In all of our previous plots, The continent variable has been sorted in alphabetical order. It starts with Africa, then Americas, Asia, Europe, Oceania, etc. When you look at them, there's no clear numerical ordering to these box plots. The median goes up and down and up and like that. So what we might want to do is reorder them so it goes from lowest to highest, as exemplified in this plot on the right. We can change the method used to order the box plots using the reorder function. Let's look at the syntax of the reorder function. It has a minimum of 2 or 3 arguments that you supply in order to tell it how to reorder the categorical variable. The first argument we want to give reorder should be the categorical variable that we want to sort. In this case, we want to sort the continent variable, which is a categorical variable, so we put that as the first argument. The second argument is a numeric variable from the data. We're going to reorder the categorical variable based on values in the second variable that we specify. This will make more sense in a minute when we do an example. To do the example, we're going to use the following syntax. We first add the categorical variable, then the numeric variable. So here we're going to change the x argument of our box plot to reorder continent life exp, because this is the categorical variable we want to reorder by this numeric variable. So I'll quickly just show you what the last plot looked like. Here we see that it's not ordered by life expectancy, and now if I take this and replace it directly with this reorder function, which I can just copy and paste in, and in this plot it might look like the box plots are arranged by median life expectancy. This solid line in the middle, as we know, is the median of each box plot, and we see that they steadily increase. But actually, the function being used here to sort the box plots is the mean of the life expectancies for each subset for each continent. But we can change this by adding a third argument to the reorder function. The third argument in reorder should be the name of an R function. Say if we want to get the median of each subset and order the box plots by median, we'll simply add median at the end. If we want to sort the box plots by the maximum life expectancy within each subset, we put max, M-A-X, because that's the name of the function in R that calculates the maximum value in a numeric variable. So let's try both of those now. If I add median here and run this code, we get an identical plot to the previous one, because in this case, ordering by the mean and ordering by the median gives you the same order of continents. But what if we sort by the max? Here I replace it with max, and if you run this, we should get a slightly different plot. Here it's hard to tell, but if you look at the very highest value for each one, you see that they're slowly increasing, so that the top of each whisker gets higher and higher as you go from left to right. It's not sorted by the median or mean anymore, as you can clearly see that the ones in the middle have a higher median than the ones on the sides, but their maximums are lower than the maximum one in Asia. You may have also noticed that the box plots are arranged in increasing order of whatever function or whatever method we give to the reorder function. When it was median, it went from lowest to highest. When it was maximum, it again went from left to right, lowest maximum to highest maximum. But we can change it to descending order if we'd like. To sort the boxes in descending order, we add a negation or a negative sign to the numeric variable that we want to sort by, in this case, life expectancy. So here's the plot we made before when we sorted by median, and it goes from lowest to highest. If we want it to go from highest to lowest, simply add a minus sign in front of the numeric variable, the second argument, and when we run this, you'll notice that it goes from highest to lowest in the opposite order. Now it's again time for you to practice in the RMD. In this question, you want to take your code from the previous practice question and retain all the modifications that that question asks you to make. You're just simply going to add on and modify the parts that we ask you to change in this question. When you've got it right, come back and I'll explain the next practice question. Welcome back. I hope that practice question went well, and your answer should look something like this plot over here. For this question, again, you want to take your code from the previous answer, paste it in, and then make the modifications asked for in this question. Here, we'd like to add labels to our plot to change the X and Y axis titles and add a main title at the top of the plot. So pause here, go to your RMD, and come back again when you've finished this question. If you got that practice question, great work. Just to double check, your plot would look something like this. You can see that the title and X and Y axis names have also changed. In this section, we'll be looking at how to add an additional layer of points to our boxplots with the geom_jitter function. As we mentioned before, boxplots provide a high-level summary of the distribution. They summarize 5 numbers in the data, the median and the interquartile ranges. The problem with this is that summarizing also means that we lose information. For example, let's consider our basic life expectancy box plot from earlier. So I'll replot that and take a look at our resulting plot. Here, it could be easy to conclude that Oceania and Europe have kind of similar distributions and ranges, except Europe has a few outliers here, and that overall they have much higher life expectancy values than the other continents we're looking at here. However, before making these conclusions, we need to keep in mind that we can't see the underlying distribution of data points in each of these groups. We also can't tell the number of observations in each group. We can see what the median is, but how many numbers are we getting the median from? What is the spread of these values? To know more about that, we can add a layer of points to the boxes. So one way to do this is to add a second geometric layer, and you might think to add points, we can just use geom_point as we have done earlier. Let's see what happens when we run this. We do get points on our box plot. However, geom_point has plotted all the data points into vertical lines. That's not very useful since all the points overlap with each other directly, and so we can't actually see how many data points they are. It just looks like solid lines, and here there could be 20 points, 100 points, 200 points, we don't really know. One solution to that is to use the geom_jitter function. ggplot allows us to randomly jitter points horizontally with the geom_jitter function. Let's see what that looks like in action. So here with the original life expectancy box plot code, I will add geom_jitter instead of geom_point. And the resulting plot looks like this. The data points that were originally arranged in a vertical line have now been moved to side, so you can see much more clearly that there are a lot more points in Asia and Africa than there are in Oceania, for example. We can also control the width of the jitter, which means how far you want to move the points side to side. We'll do this with the width argument. So here I'm going to set width equals 2. You can choose a numeric value. I'll just do 0.2 and let's see how that looks different. You'll see here that the amount of jittering is much smaller, and so we get this tighter area where the points are arranged. We can also change things like alpha, shape, and all other arguments that we've applied to geom_point before. So I'm going to use alpha here and set it to 0.5 to make those points a little more transparent and match the rest of the plot. Here some new patterns appear clearly. We can see that Oceania has a much smaller sample size compared to other groups. Originally, we thought that Oceania and Europe were quite similar, but here we can find out that actually in Oceania, we're sampling much fewer data. So that's why there's less variation in the data, because we have less data points. In fact, if you look back at the data frame, you'll notice that only 2 continents have been classified in Oceania, which is Australia and New Zealand. And since we are recording data for 12 years for each country, there are a total of 24 data points that are being summarized here. Those kind of things are important to keep in mind before we make conclusions from our data. Now it's time for you to practice. Just as we did in previous practice questions, you're going to build on the code that you last wrote. So you're going to take your plot from practice question 4 of GDP and keep all the same arguments that you did, including the labels, the scale transformations, and everything like that. And then you're going to add a layer of jitter points on top of your question 4 plot. Then for question 6, you're going to do the same. Take your code from question 5 and then make additional modifications. And when you're ready, you can use the check functions. Also, if you want a hint, there are also hint functions for these, which you can type out and run to get some code. So pause now, go into your code along RMD, and do and check your answers, and be back whenever you're done. Welcome back. I hope that practice question went well. Your answer should look something like this, where we've reduced the width of the jitter, added some transparency, and your labels are the same as what you had last time. Before we wrap up, let's look at a final modification we can make to boxplots. Sometimes you may want to add markers for the mean or average on a boxplot. The boxplot middle line shows the median, but sometimes you would want to compare it also to the mean. So the way we can do this is with a stat summary function and add a statistics layer. If you think back to the grammar of graphics layers that ggplot is based on, statistics is one of the grammar of graphics. So here we'll start with the original life expectancy code again, and I'm going to add stat summary. And then the arguments within this, first you're required to specify a function, the fun argument, which stands for function, and we want mean. So we'll put mean and remember to put it in quotation marks. Next, we want to tell what shape we want to plot it in. So you have to give geom, and the geom argument, set it to point. Let's run this and see what that looks like. So here on the plot, it's not very easy to see, but you can see that there are these small points that match up with the average of the data. These aren't very clear, so let's go ahead and make that point bigger. So I'm going to change the size to 3, and often the mean is shown with a diamond, and so we're going to change the shape to shape number 23, and additionally we're going to change the fill color to white. Now these are all arguments we've learned before with geom point, and they also apply here. So now you can see that there's a slightly larger diamond. That means you can add mean markers onto a boxplot if desired. This brings us to the end of the boxplot lessons. Just to review the learning outcomes, you've learned how to visualize the distribution of continuous data using geom boxplot and make further modifications to fill in color. You can reorder the side-by-side box plots with the reorder function and choose different methods to arrange the boxes, like arranging by mean, median, or maximum. You can also add a layer of individual data points with geom jitter, control the width of the jitter area, and make other aesthetic modifications to color, size, transparency, etc. So I hope you found this lesson useful, and I'll see you in the next one.